Morning student. Today we are going to learn about the detectors in detail, and I have in the previous class I have talked about the ideal characteristic of the detectors. So hopefully you remember, and if you look into the detail of the detectors today, I have focused here only three different type of detector. In spite there are large number of detector which is used in GC, but these are the three main type of detector which you need to know at the level of at this level as an undergraduate student. And if you ask me the other different type of detectors, there are photoionization detector, there is a electrolyte conductivity detectors, there is a mass spectrometer attached detectors, and many more like nitrogen, phosphorus based compounds detectors. So here we are going to learn about the flame ionization detector in detail, thermal conductivity detectors are in detail, and electron capture detectors are in detail. So first I will talk about the flame ionization detector. Hopefully if you remember, I classified the whole detectors in two categories. One was a mass based and other was the concentration based detector. So you look here, the flame ionization detector is belongs to the category of mass detector. The meaning is that the sample which you are going to use in this is going to be distracted. So how does it happen? How does it detect? And what is the level of uh, limit that this detector can't detect? So I have just mentioned the summary of whole detector. If you look into the slides or in the notes, I have given you the summary of the detectors and its detection limit and the uses. Particularly the detectors are even used based on the sample for what you are going to detect, as well as the mobile phase which you are going to use. So look, I will just explain here. If you see it here, you can see there is a collector here, insulator, air, hydrogen, and there is something called uh, hydrogen air mixture, and there is a flame, right? So what basically, if you look into this diagram, you understand that there is a something called flame is looking here, and the name itself for flame ionization detector indicates a part of it. So what happens when the sample eludes from the column after the separation, and when they go for the detection, they mix with the flame. They mix with the hydrogen and air, and they get it burned. And say when it burns, particularly what happen, it generates ions. So those ion, with the help of a collector, they are collected and generates the electricity or current. And the current generated depends upon the ion generated. And this ion generated depends upon the two things, how much was the sample and what is the sample. So this is the principle. If you look into the principle, this is the basically the principle of flame ionization detectors. So in a Skoog, if you read the book Skoog, they write it like this: a few hundred volt is applied between the burner tip and collectors, and electrode located above the flame, and the ion and the electron moves towards the collector and resulting into the current, and the current is very small. It is in the range of 10 to power minus 12 ampere, right? And so it is very small, and it's measured with the help of high impedance picometer. So now we can understand the use of flame. I mean, you can understand the principle of flame ionization detector. Let us come to the thermal conductivity detectors. In thermal conductivity detectors, you can see something called flow in and flow out. So what does it flow and what does flow out? So it is nothing but it is a sample after the separation from the column. When it moves for the detection, uh, If you look into this, right, I will just give you an idea. You might have studied about the Wheatstone bridge, right? So a Wheatstone bridge is what, it's a balance. If you look into the reading of galvanometer into the center of Wheatstone bridge is a zero. The meaning is that the two arm is being balanced. So both arm, when the current flow is balanced, the galvanometer reading will be zero. So what happened in this, when the sample, when there is no sample is coming out from the sorry, when the no sample is coming out from the column and only the mobile phase, means when the gaseous is moving, there is no imbalance between the two arms. And as the solid, or as the sample, right, separates into the column and moves out, and they makes in the imbalance between the two arms of the Wheatstone bridge, and that way it leads into generation of the it leads into the generation in the reading of the galvanometer. And the amount of the voltage which is being developed there depends upon how much is the current flowing and how much is the and what is the sample, right? So it tells you, and you can look at here. If you look into the nature, right, I talked about the classification of detectors into mass and concentration based. You can understand here where it belongs to, right? It belongs either to the mass type or it belongs to the concentration type. You can understand that what happened to the sample, right? Sample can be collected back, so it comes to the classification of, you just let, I mean, just you can answer this in the question provided for you. Now, and if you look into the limit, right, if you look into the limit of the thermal conductivity, it can detect till the 500 picogram per ml, and it is generally is also called universal detector, right? It's also called universal detector. Flame ionization detector is a hydrocarbon based detector. Let us come to electron capture detector. So something called electron capture detector means electron is being captured. So there will be something which is generating electron, right? So here is a something called beta emitter, right? And it's made up of generally it's a generally, beta emitter is generally nickel 63. It's a radioisotope of nickel, and the atomic number is atomic mass is 63. Atomic number is 63. So this act as a beta emitter here. So what happened when the mobile phase is flowing and beta the electron, right, the electron which is generally emitted by this is not being absorbed, right? Once the sample, right, once the sample start coming from the column and it moves with the mobile phase, and when it passes through the beta emitter, it captures certain electron, because ions may be either positively charged or negatively charged. So the positively charged ion present in that absorbs this electron and decreases the current generated, and this gives the idea about that how much and which is the sample which is being released or which is coming out. This is generally used, if you look into the use of electron capture detector, it is generally used for the compound containing halogens and then pesticides. So this three type of the detector which you have to study in detail. Let us come to the next slide. So you can see it here. I have classified the typical a glass chromatography detector, that's a flame ionization, thermal, electron capture, and so forth, so on. Now, apart from this, we need to learn about the temperature programming. So why do we need a temperature programming? So when the sample is eluting out, or when you load a sample in gas chromatography, basically the sample is a mixture of many compound, and their boiling point or vaporizing point will be varying, right? So with one set of fixed temperature, you cannot separate all the sample. So it can be either best, it can be isothermal programming, or it can be the programming of temperature. It can be either isothermal or it can be temperature programmed. So what is the meaning of temperature programmed and what is the meaning of isothermal? So look here, it is just right. You must always remember, most of the column are constructed and fused into thermosetting so that usually they don't lose heat, right? So column temperature is important variable that must be controlled to a few tenth of the degree so that the measurement is precise. The column is housed in a thermostat oven. The column temperature is justified based on the boiling point of the sample. For a sample with broad boiling range, it is often desirable to employ a temperature programming which column temperature is increased either in a thermal or in a programmed way. So if you look into the three of this diagram, you can see that the temperature is 45 degree, temperature is 145 degree, and the other is programmed temperature. The meaning is that with respect to time, there is increase in the temperature to 1 degree, 2 degree or Orion setting. And in one, that the temperature is fixed, right? It will raise till 145 degree, or the temperature is fixed to 45 degrees. That's isothermal, right? The temperature is constant. So all that sample, right? All that sample which is within the range of 145 degree will elute out. You should always remember what happened when the sample is not able to meet to their vaporization point. Samples spend time with the column and they start sticking into the column, and the illusion out will be very difficult. And if you increase the temperature to a higher extent, it will move so fast the resolution is not achieved what we desire for. So in that cases, you have to program your temperature in such a beautiful way that separation happen with a programmed manner, the meaning that as you want and the resolution is achieved. So this is the diagram which I have taken from Skoog, right? They have beautifully explained it. So make sure you read it from there. So let us next come to the derivatization, right? Derivatization technique in GC. So why do we need a derivatization in GC? So when you ask me, the purpose for going for derivatization is something to be achieved. So what do you want to achieve in this? So it is just meant to do the transformation in analyte, right? So that the detection in gas chromatography becomes easier, right? So generally derivatization is aimed to improve suitability, efficiency and detectability, right? So how do we do that? So most of the how do we do that? Just let us look into first to the nature of the compound. So generally, if you look into the nature of the nature of the compound, it contains either hydroxy group, carboxy group or amino group, or this group which I have are amine group or imine group. So when you look in this compound, they have gotten a tendency to form hydrogen bonds. So when they forms a hydrogen bond, what happened? The vaporization, right, become little difficult, right? So we do make a change into this so that the attaching purpose or the vaporization become easier. So how do we do that? So we I just look at the analysis of relatively non-volatile compounds become easier, and the reduction of volatility of the compound prior to gas analysis and improvement in analytical efficiency is being achieved for the compound which generally contain this. And down to this, how do we go for derivatization technique? These are the certain compound through which we do the alkylation type of reaction in order to bring change into the compound. So the common derivatization reagents used for alkylation type of reactions are dialkyl acetals, diazoalkenes and pentafluorobenzyl bromides, boron trifluorides and the other mentioned here. Apart from this, other alkylating reagent can be used alone to form ester or ether or amide, so that can be used in a conjugation with acylation or selenation reagent. Thank you. Take care.